Welcome in our presentation about the students' mental models about the apparent motion of sun and stars. I'm Hans Bekaert. I'm a physics teacher for more than 25 years now, and since 3 years I work as a PhD student on this research project. I'd like to thank my supervisors Mieke de Kok, Hans Tegen, Wim van Doren, and Hans van Winkel. In this study, we'd like to investigate the opportunities for learning of astronomical concepts in the context of a planetarium. We focus on the apparent motion of sun and stars. So our goal is to optimize the learning environment at secondary school and in the planetarium concerning the apparent motion of sun and stars. The research question we'd like to answer is, which mental models do secondary school students use while answering questions about the apparent motion of sun and stars? In a first step to answer this research question, we designed a test instrument. We disentangled the different characteristics of the apparent motion of sun and stars for different times during the day, different times during the year, and different positions of the observer. We ended up with 12 multiple choice questions, and we also asked for an explanation. We validated these questions in different pilot groups, and we checked reliability. We reported on this and in an article which is published in Physical Review Physics Education Research. For example, here are two questions about the daily motion of the sun and stars. So you see, for example, on March 21st, an observer in Brussels sees the sun in the south high above the horizon as shown in the figure. Where does the observer see the sun 1 hour later? And then we have 4 alternatives, and we also added an extra alternative, I don't know, because we didn't want the students to guess. We also ask for an explanation, and so for every element of the apparent motion, there are 2 parallel questions, what makes it possible to compare differences and similarities about student thinking about the apparent motion of sun and stars. We administered a test in 6 Belgian secondary schools. So there were 410 16, 17-year-olds who participated in the study. We planned to test after the astronomy lessons in school, which are in the geography course during a lesson at school. For the first analysis, we scored the multiple choice answers, 1 for a correct answer and 0 for a wrong answer. Here on the right, you see an image with horizontal the number of correct answers and vertically the number of students. So you see most students have 6 or 7 correct answers on the total of 12. We have also asked the students to explain their answers because we want to get insight in students' ideas. So in the mental models they use, and we'd like to describe these models. That's why we have designed a categorization scheme. And we found in literature that understanding these basic astronomical concepts, it's only possible if you can switch between a geocentric point of view and an allocentric point of view, let's say the view from space. So we focused on these elements while reading the students' answers, and we created the classification system bottom-up from student answers. Based on this classification of student answers and based on a statistical analysis of the multiple choice answers, which we call latent class analysis, we can identify 4 different student groups with their own way of coherent thinking concerning the night sky. The first group is the biggest group, and these students treat the stars as copies of the sun. So they say, okay, the sun and stars move from east to west during the day and night. In summer, the path is higher and wider. And when the observers change latitude, when the latitude decreases, the path becomes higher and wider. So for the sun and the stars, like you see in this example, the student writes March 21st. This is spring, just like the sun in summer, the star will accumulate higher than in spring. The next group is we call the stars imitate the sun group. So they know sun and stars move from east to west during the night and the day. And then they say, okay, in summer, the sun path is higher and wider than in winter because days are longer. And then they say in winter, the star trail is higher and wider because nights are longer. So you see this here on this example, nights becomes longer. Stars make a longer star trail. You see this on the drawing. This is the star trail for September, and this is the star trail for October. And in the same way, the students make this reasoning. So when the observer's latitude decreases, the sun path becomes higher and wider. And when the observer latitude increases, the star trail becomes higher and wider because their nights are longer. The third group is the fixed sun path and star trail group. So these students know stars move from east to west during night and day, but they say sun path or star trail does not change throughout the year, rising in the east and setting in the west. So for example, like here, like the sun, stars always set in the west. And then the fourth group is about the fixed stars. So for the sun, this group knows the sun moves from east to west and the sun path is higher in summer than in winter, but the stars don't move during the night. For example, the student writes here, the Earth spins, but the position of the stars stays the same. So we can say we have identified 4 kinds of coherent thinking, but we also found that most students don't seem to have a mental model which is robust and coherent, which they use to answer the different questions of the apparent motion of sun and stars test in a coherent way. So you see here an example. In one question, the student writes, the star turns always in the same way and its height does not change. And on another question, the student writes, stars always set in the west. Thank you for your attention. Please contact me if you have any question. Bye.